Hello, my name is Steff. I'm one of the co-founders of Ecoloct, and I'm very excited to be here today and tell you more about how and why we turn buildings into carbon sinks. We all know we need to massively scale up carbon removal, and with that we need to find ways to store permanently and safely the carbon and to finance that removal. The answer to both of that is carbon utilization. So taking that carbon and turning it into value-adding products. One very promising carbon sink, so an industry to use those products, is the built environment. You probably have heard just building materials contribute to around 15% of the global annual emission. And just half of that is cement alone. Just to put that in perspective, the whole aviation industry is about 2 to 3%. The vast majority of the embodied carbon in the built environment is also coming from the concrete and the cement specifically. So there is a high dependency from all the other players in the value chain for the cement producer to decarbonize. And unfortunately, current studies show that even in best case scenarios, still around 25% of the emissions of cement will remain even in 2050. So what is it that we are doing? At Ecoloct, we are taking atmospheric captured carbon and turn it into functional CO2 negative building materials. The potential for that is huge. Each year there are more than 3 gigatons of waste biomass available globally. And right now we are able to put around 200 kilograms of CO2 into a cubic meter of concrete. That would lead us to around 1 gigaton of CO2 impact by 2040. So this is our goal. So what's the challenge? So on the one side we have this input, which is the waste biomass that is pyrolyzed and thereby turned into biochar. And biochar is by no means equal to biochar. It is hugely different in terms of its functional and chemical properties. That means we have here a very fluctuating product, and on the other side, the concrete industry, construction industry, they need very, very consistent material in very high volumes to embed into their material. So Ecoloct is really in the middle and combining those two completely separate worlds. We have the Ecoloct platform, which is a digital tool and a number of databases that help us to understand the chemical and physical properties and predict the performance of those in the end applications. So we are able to select the best fitting, most appropriate material in any given situation. And the next thing we are doing is we are physically refining it. So we are post-processing the material. Because if you would just take the biochar and put it into the concrete, basically you would have performance issues. The quality would drop. And this is the last thing you want for structures that should hold for multiple decades. So what we are doing is we are refining this material. So in the end, you have a very high quality, consistent material that is easily integratable at the construction site. The market we are looking at right now obviously is huge. Concrete in general is the most used material on Earth after water. CAGR still 6%, growth happening especially in China and the developing markets. For us, we are currently especially focusing on the non-structural market. Reason for that is certification, the norms and standards. But we are also able to stack into the structural concrete in a few years. So the market is only getting bigger. Here you'll see the video of how it exactly it looks that we are doing. So this is our concrete lab. Lots of testing, making sure that as we embed the biochar, the material, and we refine it into the concrete admix, that it actually we have really high performance of the end product. So yeah, you can see we are beyond the lab phase. We are already in the market. Our first product is ELM0, so it's a concrete admix material helping you reduce the CO2 footprint. We are working in the RMC, ready-mix concrete market, in the precast market. We are working in architectural concrete, paving stones, screed. So there's no end, and long term, obviously, we're looking into other building materials, thinking asphalt and things like this. So far, we have poured 350 cubic meter of concrete, resulting in around 60 tons of CO2. Those numbers are really small, obviously, but it is the first step, and from here, we are only going to scale up. All of this, of course, is externally verified. So this is what you'll see here. At the very left-hand side of those charts, you see the footprint of a concrete that is already CO2 reduced. So probably it already has been treated with some kind of CM or some alternative binder. But of course, it's still way too much. So this is where our biochar-based material comes in. We replace some of the sand, we replace some of the cement. With that, we have some emission reduction, but the vast majority really comes with the sink potential. So taking this solid carbon and locking it into the concrete. With that, we can go to neutral or negative, depending on what the starting point was, and obviously the technical requirements on the concrete. All of this, of course, is fully externally verified. So this is nothing that we track and just say, trust us, but this is with all the well-known providers that track CDR certificates. This is my favorite slide. It's actually talking about the compatibility. And I think this is hugely important because everyone is obviously excited about their own technology. But I really believe there's no one technology that will bring the whole industry to a solution. For that, the challenge is too multifaceted, too complex. So we need a whole toolkit of different solutions that we can apply. And some of these are really well established already in the industry. Others are very emerging and not really at scale yet. But at least all of the large technologies that are out there to reduce the CO2 footprint are highly compatible with our material. And what I think is even better, it creates great synergy, so that 1 + 1 is not 2, but actually 2.2, 2.4. So they benefit each other, and we increase the impact. And I think this is really exciting. So if you are working on any additional new technologies that are not on the slide and we haven't verified that we can work with yet, let us know. Happy to do some joint tests because the industry loves also that. Here you can see the manufacturing process. I mentioned that already. Just taking biochar and dumping it in concrete will not work. There will be performance issues. So we need to also refine this material further, the post-processing, to really make sure this is a material that in the end can very easily be integrated. And this is a big component in how we are thinking about scale, because in the end we will not be able to do all that alone. This would be a very asset-heavy business if we were to do that. So we are really looking at building ELM hubs that we can then also license out to either our customers or our suppliers, and this is how we will really reach scale very fast and bring down the unit economics a lot. So this is how we imagine it in a couple of years. We call it the McDonald's model. So we will have a few hubs that we operate ourselves. It's just important to make sure we still capture the learnings, we operate and see what the issues are. But we will also license this out both to customers and to suppliers. The beauty in this is that if you're familiar, concrete is a very local value chain. You can't transport ready-mix concrete more than 50 kilometers. So you have a lot of small plants everywhere. Waste, bio-waste is also available everywhere. So you can really have here hyper-localized value chain, very, very decentralized. And this means we really also have a good hold on the transportation emissions. Here you can see our team. I won't go into detail. At this point, we're around 20 people, very strong in a lot of different areas. Right now, we have closed our second funding round. We are just building up our pilot plant. We are coming in at around 1,000 tons of offtake this year, looking to raise Series A second half of next year. So anyone interested, let us know. We are not only looking at equity financing, but also venture debt and CapEx financing. So again, anyone who is familiar with that, happy to discuss. And finally, most importantly, always looking for joint projects to lock in more carbon. So anyone here wanting to build some concrete, let us know. Thank you.